because the DO, as soon as you take the flask out of the shaker and leave it on the counter, it's going to eat up, it's going to take up all that oxygen that's there, and there's not going to be more going in. So it's going to have a dissolved oxygen drop during that time, and it's also going to chill. So all of those things could affect the outcome of your process. So you always want to take care of that initial step of inoculating your environment. Okay. So this is a list, and actually this is a useful list of things, and you might want to think about this. You may not do all of these things, but someday if you work in a company, these are the things that you want to keep track of in terms of the inoculation of your reactor. First of all, volume of your frozen stock and the lot number. The shaker details, the temperature and RPM of your shaker makes a difference. What's the media like that you're going to inoculate with? Should it be pre-warmed? When you put the inoculum into it, how do you thaw your inoculum? All those are steps that matter. The metric for the inoculum, okay? Is it ready to transfer next when the optical density is exactly 1? Or what is going to be the metric that you're going to use to determine that you're ready to move on to the next bioreactor? The time of inoculation. Okay, what time did you start your inoculum, and what time did you put it into your bioreactor? And after you put it into your bioreactor, take a sample. What is the initial optical density of your fermenter? What is the initial pH, temperature, and volume? And while we're at it, take stock of that glucose concentration. You also want to know there's usually what's called post-sterile additions. There are post-sterile additions in our process too. After you autoclave or sterilize the bioreactor with we're going to use LB broth with 5 grams per liter glucose in it. We're going to inoculate we're going to autoclave the LB broth without the glucose in it. Then we're going to add the glucose from a solution that you're going to autoclave separately. Okay. So this would be a post-sterile addition. Would be sterile glucose. We don't need to eat vitamins. We don't need to add vitamins because there's plenty of vitamins in LB broth, so we don't need to do that. But so the only thing you're really going to need to add is the glucose solution, and then we're going to add the inoculum at the time 0 of the process. Write down the time, start the process, and that's going to be you're going to begin your process. One other thing that you could add, although we won't need to add it, is the inducer. If your plasmid that you have the gene that is expressing the protein you're trying to produce has a promoter that has an inducer associated with it, such as the LAC promoter. And at some point in the run, when the optical density reaches a certain value, you're going to add your inducer. Because in our process, the LB medium seems to have a molecule in it that induces our expression. We don't need to add inducer. That inducer will already be in it. So that would be an example of another post-sterile addition. Okay. Okay. Then other things might be added like vitamins or other molecules. Okay. We also need, sometimes, although with LB medium you don't need to do it, but sometimes you need to add acid or base to bring the media to the proper pH. All right. We also need to calibrate the DO probe and the pH probe. Those are going to be autoclaved in the fermenter, in the medium, so that it's ready to go. All you have to do is connect it to the electronic device and turn the system on, and you're good to go. But we do need to calibrate it at that point. And so that's done after you sterilize. Okay, then we start the airflow. Take note that this should be filtered air. It should be sterile air going in the bioreactor. And at that point, we will be following and monitoring the off-gas and any other observations that were made for something that might have gone differently. Well, if you're only doing it once, there's nothing different. It's all different. So you don't need to think about that. But you might want to write down if there was something that you noticed that you thought was strange or that you weren't expecting. You can write that down. With luck, I'll be there to ask you some questions, and then everything seems normal, then we're good. Okay. Then, once the reactor is running, we're going to take samples. So we're going You can note down the time of the sample. When you take the sample, you're going to write down the weight of the scale that is that's got the bioreactor on it, so that we keep track of the volume of the system when you take that sample. Okay. Keep note of the optical density that you're going to measure from the sample, and then you're also going to measure the glucose, so we're going to write all that down, or you're going to write it down in your laboratory. Okay. So these are things that are also important. The time you started the feed, okay? We started with the inoculum, and then after a certain elapsed time, we will start the feed. So you want to write down when did you start the feed, okay? And then any details of the reactor associated with the feed start. Okay? Was it an optical density? Was it the glucose concentration or pH spike? And we are, especially if we don't have the glucose meter working by the time you do your fermentation, it's going to be a pH spike. But maybe we will have the glucose meter, and then we can turn it on based on the glucose concentration. Okay. And then also we are going to pay attention to the feed rate and any composition changes. Okay. So then what's important about taking samples from the bioreactor? Okay. A representative sample will give the most meaningful analysis. It's important that we not take the sample as what's been sitting stationary in the sample line since the last sample. So normally you push sterile air through the sample line, and that pushes the liquid out back into the bioreactor that was in the sample line, and then you pull the sample. Our sampling device is set up for that. It's got a little syringe on it and a little filter, so you're going to push the air through, you're going to see poof in the bioreactor, and then you'll pull your sample out, and that will be a nice representative sample from your bioreactor. Okay. We don't have steam in place. This is done, in industrial settings because it makes sure that you sterilize, so you can't contaminate the reactor when you take a sample. This is really important if you are using a wild-type organism, because this is the time when you would possibly get contamination in your process. Okay. So let's think about our media. So we're going to use a complex medium, which makes our life much easier. But let's think about what's in the bacteria. We need carbon, nitrogen, oxygen. Okay? All that's going to produce our biomass product, and then some byproducts, CO2, water, and heat. So what is the principal components of the fermentation media and their significance? Okay, we are 50%